Hey everyone, so today we're going to be talking and building off of what we talked about last time with greenhouse gases. We're going to be talking about feedback loops and then also something called the enhanced greenhouse effect. So in terms of looking at Earth and the atmosphere and the climate on Earth, the Earth's temperature can really change due to a number of different reasons, not all of which are listed right here. So variations in the amount of solar radiation that is not only coming to Earth, but then also coming to the Earth's surface, global dimming, feedback loops, and then the enhanced greenhouse effect. And all of these will be gone over today. So in terms of the first one, variations in solar radiation, this really refers to a change in just the output of energy from the sun, whether it's a solar flare, whether there are clouds in the sky not being able to come to, the surface, whether it's blocked out or reflected back into space. All of these things can sort of, affect the temperature here on Earth. But then there's also evidence that sometimes the axis or the tilt of the axis or the ways in which, the sun is in a certain cycle, there is evidence that these things can change. And not only is there evidence of an 11-year solar cycle, but there's also a term used to refer and to define these changes in the Earth's tilt or the Earth's axis that sort of affect the climate here on Earth. And these are called Milankovitch cycles. Now, there are always small variations in the Earth's orbit, which affect the seasonal and latitudinal distribution of solar radiation. So basically, how that is spread here on Earth and how that affects weather. And these can be, over time, responsible for initiating ice ages based on the tilt of the Earth, based on, how much radiation is coming to Earth. It can change how much ice we get here on Earth. And so these changes to the atmosphere can disrupt the natural balance of the Earth's energy budget, right? How much we are able to use or spend before we start warming or cooling the planet. All of these things can really affect, our ability to sort of judge how much we are using here on Earth. The next reason for why the Earth's temperature does change is something called global dimming. And this just refers to the reduction of the amount of light at the Earth's surface. And most often this is caused by air pollution and is seen as a man-made thing. It's not just fog that causes global dimming, but rather air pollution being there that can, sometimes cause massive effects. In fact, there's an estimate that between 4 and 20% of the possible sunlight is sort of blocked out and is sort of dimmed. And this can lead to a really cooling effect. Okay, there's less radiance to come through. Okay, it's not as sunny because the sky is blocking it out. And this is not only bad in terms of having colder weather, okay, but also it can sort of mask, faster global warming because we're not feeling it here on the surface, but that doesn't mean that the Earth isn't getting warmer because of this. Okay, and in fact, even after 9/11, all flights were grounded; they weren't allowed to fly for about a week, and the temperature rose on average 1.1 degrees Celsius, and so even that just shows how much warmer it could get with the absence of air pollution and the damage it's already done to warm the planet. Now that gets us into an idea that's really going to be central to this unit, and that's the idea of feedback loops. So a feedback loop is a system where the outputs or the results or the consequences of the system can lead to the system either becoming amplified or inhibited. Okay, so a positive feedback system is going to amplify the results. Right? It's going to make it much worse because it's sort of the outputs sort of cause each other to continue to get worse. And then negative feedback, it inhibits the system. It stops it from possibly doing some very positive things that it needs to do. And these feedback mechanisms really play a key role in controlling the Earth's atmosphere. And when we have changes to these, like have occurred with air pollution and have occurred with some of these things that are causing global warming to occur, it can really have huge implications for the climate and can lead to a change in mean global temperature. And so, just looking a little bit closer at positive feedback, there are some positive feedback systems that exist in amplifying the issues of climate change, and I'm going to talk about one here. Okay? And one is in, global warming, especially in tundra climates. So these are, areas, again, that are close to the poles. They may be just outside of the Arctic Circle or the Antarctic Circle, but they're right there. And it is believed that the effects of climate change, will be most noticeable in these areas in terms of winter warming. And so what you'll have is a melting of the polar ice caps, which results in less ice. It lowers the amount of albedo because, like we talked about the other day, ice has more albedo than water does. And so not as much sunlight is going to be reflected back into space. And, lowering this albedo will also increase the amount of solar energy that is absorbed at the Earth's surface, making it warmer on the whole in a global climate. Okay. Now, not only does that happen, but then also there's a layer of permafrost, which sounds exactly like it reads, something that's been permanently frozen. But this will start to melt given warmer temperatures in this area. And when that happens, vegetation that has been, rotting under the surface, sometimes for thousands of years, is going to be released. And with that is going to release methane, which plants, release upon, when they're decaying. And so this is going to be released into the atmosphere and therefore amplifying the problem even more, causing methane to be in the air, soaking up, solar radiation and warming the planet on the whole, and with it increasing temperatures. Now, there are other examples which I have listed there, but really the main point I want to talk about with positive feedback systems is that these mechanisms can be associated with global warming and may have some long time lags. And so, by time the effects appear, just like we talked about with like global dimming, we may not be feeling it currently, but that doesn't mean that these things aren't happening without our knowledge. And so by time the effects fully appear, they may have gone past the tipping point and we may not be able to reverse it. All right, so on the other side from positive feedback systems, we also have negative feedback systems. And unlike positive feedback systems, which amplify sort of some of the results, the consequences, that sort of stuff, negative feedback systems help in inhibiting systems and help in, sort of reversing systems on some level. That doesn't always mean that they're great, but, in this particular example, it might be a little bit better. So for one, if you have increased evaporation towards the poles, in lower latitudes, that may lead to an increased snowfall on the polar ice caps. It may mean that the global temperature may be reduced a little bit. And an increase in carbon dioxide in the atmosphere may lead to an increase in plant growth because plants, of course, take in carbon dioxide. and allow higher levels of photosynthesis to occur. And then the increased plant biomass and productivity might reduce atmospheric conditions and concentrations of carbon dioxide. A couple other examples. The first one is a little bit more negative in terms of, if you're burning stuff, it may lead to more aerosols in the air and may cause some cooling as well. And this isn't necessarily a great thing if there's an unnatural amount of cooling because of this. The planet warming along with cooler temperatures may cause some adverse weather conditions like, tornadoes or hurricanes. And we've certainly seen an increase in terms of the severity of some of these weather systems. In addition to that, you may have increased evaporation, which may lead to increasing cooling as well. Now, on the other side of this, we talked about the greenhouse effect the other day, but the idea that the greenhouse effect is a net good for the planet and helps balance things out. Well, the enhanced greenhouse effect just refers to the increasing levels of greenhouse gases that are in the atmosphere as a result of these human activities. And in terms of the enhanced greenhouse effect, you could just simply know it also as global warming. That doesn't mean that you might not get asked a question about the enhanced greenhouse effect, but just thinking about it in terms of global warming is going to be helpful. This global climate change oftentimes is looking at the global patterns of rainfall and temperature, sea level changes, habitats, and drought, floods and storms, all resulting from changes in the Earth's atmosphere, and all caused mainly by the enhanced greenhouse effect and human activities, like burning coal, like pollution, all of these different things that have been associated with this change in climate. Now, in terms of who's to blame, mostly higher income countries, HICs, are mainly to put blame on, although newly industrialized countries are going to certainly add to atmospheric carbon dioxide for sure. Okay. All right, with all of this being said, if you have any questions, please let me know, and I hope you all have a great day.